this is Harsha of BCA department from Milagris College. Today in this session, we are going to discuss context switching in operating system. So before learning what are context switching in operating system, we must know what are operating system. So what are operating system? These are a control program that manages all peripheral devices of our computer system. So what are peripheral devices? It may be input and output devices such as keyboard, mouse and printer and scanner, and it can be also user programs. So basically these operating system that is an intermediate between the user programs and the peripheral devices. Why it is an intermediate between the user programs and the peripheral devices? We know that the user programs in a computer system that do not have direct access to the hardware devices such as mouse, keyboard, scanner and the printer. In order to utilize those resources by the user program, operating system provides a chance to use those resources in a running process. Now here the user programs are also called process. So what are process? The program that is currently under execution, that has started its execution but not ended its execution, that are called process. So let's get into this context switching concept. So what is context switching then? We know that when you have multiple programs in a system, that is in your main memory, all these user programs are executed by the CPU. Your CPU is responsible in order to execute all the processes that are ready to execute. So how it will be executed? The operating system will give the access to the user programs in order to execute by the CPU, as well as operating system give access to use hardware devices by the user programs. Now that is how operating system manages hardware devices and the user programs in a computer system. Now what is context switching? So we know that multi-processing system. So what are multi-processor system? When you have multiple user programs in a system that runs concurrently, that is called multi-processor system. So or what is multitasking system? When you have multiple processors that resides in a main memory and that runs concurrently by the CPU, that is called multitasking. Now this context switching that takes major role in multitasking. So what are then context switching? Context switching is a fundamental mechanism in operating system that enables a multitasking. It allows operating system to quickly switch between the different processors or the threads, giving the illusion that multiple programs are running simultaneously. That means CPU switching from one process to the another process in order to execute. That process is called context switching. Now this process that involves saving the state of one program and loading the state of another program and enabling efficient resource allocation and utilization. Now what are the definition of context switching? Definition of context switching that involves three parts, that is saving the data, loading the state and efficient multitasking. So what are these? Saving the data or saving the state. Context switching that involves saving the current state of running process or thread, including its memory, register or program counter. So why it will save the data? Before a CPU switches to another process for its execution, it must save the state of currently running process so that it can utilize those information while it resuming this process again. So saving the state is the first step in context switching. So whenever the CPU wants to switch from one program to another program for its execution, it must save the data, save the state. So what are the state? State is the information of currently running processes. Where it will save? it will save to the control block, process control block. Now process control block is a specific task where each individual process will get each individual process control block. That means all information about the processes will be stored in a process control block, such as its memory, register and program counter, and different state, at what state it is currently. Now, what is loading state? The operating system then loads the saved state of new process or threads, allowing it to resume execution. So now it is done with the saving state of currently running process. Now it must load the data of the another process for its execution. That is what loading state. So it will load the state information of the another process for its execution. So once it loads the data or state of the process, it resumes its execution. So in between that time, context switching will take place before saving state and loading state. Now the CPU has switched from one state to another process for its execution. Now what is efficient multitasking? So this rapid switching between the processes that creates the illusion of simultaneous execution of the processes that enables efficient multitasking in operating system. Now this is a major role of context switching in order to efficiently use a multitasking. So what are the importance of context switching in OS 10? So first important is that resource utilization. Context switching that allows multiple processors to share the CPU, improving the resource utilization and reducing the idle time of the CPU. Now the CPU will be shared among all the processors in an efficient way, and that improves the resource utilization as well as the reduces the idle time of the CPU. Now the second importance of context switching is that system responsiveness. By quickly switching between the processes, that is from one process to another, the operating system can respond promptly to the user request and the events. The third importance is that enhanced efficiency. Enhanced efficiency of the multitasking. So context switching that enables efficient multitasking, that allowing the system to handle multiple tasks concurrently and improve the overall performance of the system. So we have two types of context switching: preemptive context switching and cooperative context switching. Let's see what are these two types of context switching. The first one, preemptive context switching. The operating system that forcefully interrupts the process after specific time slice, and then it will switches to the another process regardless of whether it is finished or not. Now, forcefully switching from one process to the another process for its execution is called as preemptive context switching. It will not wait for whether the process has been executed completely or not. Whenever there is an interrupt or high priority processes has come for its execution, the CPU switches from current process to the another processes forcefully. That is called preemptive context switching. So second type of switching is that cooperative context switching. So here the processes that voluntarily releases the CPU for another process for its execution. So when these will occur, typically when they are waiting for an event or when they want to wait for any input output devices. In such cases, O is allowed to switch to the another processors. Now there is no forceful switch from one process to another. The running current process that on its own releases the CPU to another process for its execution, so that it is called cooperative context switching. So I hope you cleared two types of context switching. Now what are the process of context switching? So as we learned, there are three main steps: saving the data, loading the data, and resuming the execution of the process. Now these are the three major steps that involves in context switching. So first one, save the process state. So the operating system that saves the current process register, memory and program counter before it switches to the another process. Then second step is that it will load the new process data for its execution. OS loads the saved state of the new process into the CPU so that CPU can resume its execution. So that is what in a third step, CPU will resume the execution. The new processes resume the execution from where it is left off. So if you observe this state diagram of context switching, you will learn more about context switching. Here we have two processes, which is process P0 and process P1. Now assume that only two processes. So what is process? A program that is under execution. That is under execution, that means which is executed by the CPU. So now we have two processes, process 0 and process 1. Only two processes we have in the main memory. Suppose if you assume that process 0 is executing, that means CPU is executing process 0, and after some time there is an interrupt or system call. So that now context switching must take place. That means process 0 must be stopped from its execution by the CPU. It has to switch to the process 1 whenever there is an interrupt or a system call. So we know that what are the different cases the context switching takes place. Whenever there is an interrupt or system call or utilization of hardware devices. So these are the different cases the CPU switches from one process to the another. So the process 0 stops its execution. So what is the first step? It will save the state into the PCB 0. Now process control block 0 that is allocated to the process 0. Now before it is switching, it will save the state into the PCB 0. After that, it will reload the state of process 1. So it will reload the state of process 1. So if you observe here, it will reload the state from the process 1, and process 1 will be executed. Process 1 will be executed by the CPU. If you observe, after some particular time, process 1 is also stopped by its execution by the CPU. In such cases, what is the first step? They need to save the state into the process control block of this process, which is process 1, PCB 1. So once it saves the data, they can load the data of another process that is already stopped here, PCB 0. So it will reload the state from the PCB 0 for its execution, and it will resume the execution. If you observe here, from here to here, process 0 was kept at idle. It was not executing. It was, available for, or it was waiting for hardware devices such as input and output devices. But if you observe, nowhere the CPU sits at idle. After executing process 1, it directly switches to the process 1. After executing process 0, it will switches to the process 1. After some time, it will again switches to the process 0. Now this will continue till the end of the execution of the processes in the main memory. Thank you.